It starts deep underground. This is chalcopyrite, the world's main source of copper, just 0.5% pure metal inside. First, we crush it. Then, giant steel balls grind it into a fine sand to free the copper particles. Now it's a black sludge. We add water and chemicals. The goal? Make the copper sticky so it floats. This is flotation. Air bubbles grab the copper and float it to the top as foam. The waste rock sinks. This foam is now 30% copper. We scrape it off, dry it, and ship it to the smelter. Dried into a fine powder. It looks like dirt, but this is high-value cargo ready for fire.
Into the flash furnace, 1200 degrees Celsius. The powder melts instantly.
The heavy stuff sinks. This is matte, about 60% copper. The light slag floats on top. We pour the molten matte into giant ladles. It's too hot to touch, over 1200 degrees. Next stop, the converter. We blow air through the liquid to burn off the iron and sulfur.
The reaction is violent. Sulfur burns off as gas, which we capture to make sulfuric acid.
We skim the impurities. Watch the color as the iron leaves. It turns from dark to a shiny coppery red. This is blister copper. It's 98.5% pure. The bubbles of gas get trapped, making it look blistered. We let it cool into heavy plates. It's almost pure, but for electrical wires we need 99.99%.
Back into the fire. The anode furnace melts the blister copper one last time.
We stir it with green wood logs, poling. The gas removes the last oxygen bubbles. It hits the wheel and freezes in a second. Now it's a continuous sheet of 99.96% pure copper. We cut them into plates. These are anodes, positive electrodes. They're ready for the final bath. A quick wash to remove oil and dust. Cleanliness is key for the next step. The electrolytic refinery. We hang the anodes into tanks full of sulfuric acid and copper sulfate. Inside every tank, an anode and a thin starter sheet called a cathode. We pump 30,000 amps through them. Magic of chemistry. Electricity rips copper atoms off the anode. They travel through the acid and stick to the cathode. We monitor voltage 24/7. Too high and the quality drops. Too low and it's too slow. Impurities like gold, silver, and platinum don't dissolve. They fall to the bottom as anode slime. We pump this out. It's waste? No. It's gold and silver. We send this to the refinery to extract jewelry metals. It takes 7 to 10 days. The anode dissolves away and the cathode grows into a 99.99% pure sheet. This is it. 99.99% pure copper. So pure, it conducts electricity better than any other metal. Out of the bath, each sheet weighs 100 kilos. Handle with care, they're heavy and soft. Wash off the acid, or it will stain the surface. Now it's ready for the market. We stack them on pallets. This is the standard product sold to wire manufacturers worldwide.
strapped and sealed, ready to leave the refinery. But for wires, we go one step further. To make wire, we melt the cathodes again in a shaft furnace. Continuous melting. The furnace keeps a constant pool of molten copper. Gravity feeds it to the caster. The Southwire system. Liquid copper hits the wheel, solidifies, and goes straight to rolling. No reheating. First pass, roughing mill. Squeezes the thick sheet down to 8mm rod. The looper towers keep tension. The rod snakes through more stands, getting thinner each time. Finishing block. Down to 3mm or 8mm diameter. Speed is incredible, up to 100 meters per second. Quench tank. Water cools it instantly to lock in the crystal structure. Laser micrometer. Checks diameter 1,000 times a second. If it's off by 0.01 millimeter, it rejects it. Flying shear. Cuts the continuous rod into specific lengths while it's still moving at full speed. The coiler. Winds the rod into a mother coil, up to 5 tons of copper wire. Weighed and tagged. Every spool is tracked. This one is 4.5 tons. Steel straps hold the tension. If these break, the coil explodes. Dangerous. Lifting eyes installed. Cranes need this to move it without crushing the copper. All secure. Placed on a heat-treated wooden pallet, ready for export. Shrink wrap protects it from humidity and scratches during ocean shipping. For fine wire, we use the drawing machine. We pull the rod through diamond dies to make it thinner. This is a tungsten carbide die with a diamond core. It shaves metal off without heating. Each capstan spins slightly faster than the last. This stretches the copper. Tension is critical. Drawing makes copper brittle. We heat it to 400 degrees to make it soft and flexible again. The take-up spool. This spool holds 500 kilometers of wire. .050 meter. Perfect. Even at 0.5 millimeter, tolerance is microns, used for electronics and cables. Quality lab. We zap it with sparks to read the exact chemistry. Must be 99.9%. Checking copper. It's 99.99%. Tensile test. How much can it stretch before it breaks? And how strong is it? Bend test. We bend it flat. If it cracks, it fails. Pure copper doesn't crack. The warehouse. Millions of dollars of copper waiting for customers. Loading containers. Heading to ports. This goes to China, that one to Europe. Sealed and locked. Secure for the journey across the ocean. From a dirty rock in the mine to a shiny wire powering your home.